So in the question, there are two figures A and B having system of two masses A and B with a motor M in both the cases, and there are two masses A and B in figure A as well as in figure B. So we are going to find out the relationship of velocities of mass A and mass B if the winding speed of the motor is given as V. Okay. So in this case, we are going to start with figure A. In figure A, if we say that the body B moves in this direction by x, okay, so for body B moving with a distance x towards right, and let us say this pulley is called as x pulley, then pulley x will also move, or we can say slack, by the distance x. Therefore, we have a slack of 2x. We have slack of 2x. Let us say this is 1 and this is 2. Slack of 2x in 1 as well as in 2. Okay, so it means in 1 there is slack of 2x and 2 also in 2x, but we are not interested in 2, we are only interested in 1, which is connected to the motor. Thus the motor will wind a slack of 2x because of mass B. Okay, and for mass A, let us say that mass A moves to the right by y distance. Okay, so mass A moves towards right by y. Therefore, the motor M will wind a slack of y because of mass A. So if we add the total, so this we can say, thus the total slack wind by motor M will be equal to slack of mass B as well as slack of mass A. So you can say 2x plus A, and let us say the total slack is represented by L. So let us call this as equation 1. Okay, we call this as equation 1. So differentiating the equation 1, differentiating equation 1 with respect to time, with respect to time t, we get dl by dt is equal to 2 dx by dt plus, so here it has to be y, not a, plus dy by dt. Now the velocity of the motor, or rather winding velocity of the motor, is given as v. So we can say that dl by dt will be equal to v, and dx by dt is the velocity of mass A, and we represented it by va, plus dy by dt, sorry, this is mass B, and dy by dt is the velocity of mass A, so we represented by va. So this is the relationship between the velocities. Okay, so this is the relation between the velocity of mass A and mass B with motor winding speed, which is given as motor winding speed, that is V. Okay, this is V. Okay, let me write here, this is 2a VB plus VA. Now for figure B. For figure B, let us say that mass A moves in up direction by x distance. Okay, if it moves by up distance by x, and so let us calculate for, first of all, for mass A. So let mass A moves in upward direction by x. If it moves by x, so the total slack, rather we can say slack, that is wind by the motor M due to mass A is x. Because of this x, so we are going to have the entire slack will be wound up by mass m, because of A will be equal to x. We are not interested in how this pulley moves up and down, because motor is connected directly to the mass A, so the entire slack of x will be transferred to the motor directly. Okay. Now in the second case, we assume that mass B moves upward in y direction with the y displacement. So for mass B, let it moves upward by a distance y. Now why this motor B is mass B is connected at two places, so the right side moves by y, and this pulley is also going to move by y. Okay, so we can say that moves upward by a distance y in the on the right side, and also pulley, let us call this as pulley x, let us call this as pulley x. So pulley x also moves, so pulley x also moves by a distance of y. So it means now this pulley is moving upward by y, so we are going to have a total slack of, we can say, a total slack of 4y, because of all the combination of right side as well as movement of pulley y. Okay, you can say that thus therefore the total slack cause of the mass B will be a summation of slack on the slack because of the right side and slack due to pulley. This will be equal to 4y. Okay, so therefore the total slack, or we can say thus the total winding for motor M will be equal to x plus 4y, and let us say it is equal to L. And differentiating once again, same method in which we did in figure A, differentiating with respect to time. we get this as dl by dt is equal to dx by dt plus 4 dy by dt, and dl by dt is nothing but our velocity of the motor, so this will be v. Dx is our velocity of mass A, so va, plus y is the displacement of mass B, so this will be vp. In this way we can find out the relationship with the winding velocity, velocity of mass A and velocity of mass B in the figure B as well. Thank you.